Okay, today I'm going to show you how to create a job using Spark Batch in Talend to solve a problem of aggregating a ClickStream data input. The input we're talking about is basically the log of users using our website. So this file is going to be very simple. It will have a schema of a user ID. It usually would be a cookie or something like that, so a hash, but in this case I just wrote users. The start date and time of the user's actions on the website, and when he left the website. Now, a user could have done more than one entrance in the same day. We want to aggregate this user actions on the website by session, and the definition of a session is if the user had 2 entrances within 30 minutes of one another. So if I did something on the website at 12 and then I did another thing at 12 and 10 minutes, I want to aggregate those 2 records into one. If it was later, only in 2 o'clock in the afternoon, that would be a new session. Okay, so let's talk about a few things. First of all, the reason why we don't do it in a normal job or a normal query is because it's big data. I mean, I've run into use cases where you have a daily input for a big website of 500 gigabytes, and think about running aggregation on this kind of file, and if it's more than one day, it's even much bigger. So you cannot just use any normal Java or any normal process that you would normally do. Second thing is you cannot use SQL so easily because you're aggregating row by row. That's not simple SQL query. You would need some more advanced features of SQL. So normally you cannot just use Hive. You would be able to use Hive, but you have to create another UDF for that, and that means a lot of code, and that's not really SQL anymore. So possible ways to do it is, one, if you write a MapReduce code, okay, that means that you have to know how to do it. It's harder. Not a lot of people are very good in MapReduce, and it's also very hard to read. So if one person wrote it, it will take a while until another employee or another person can understand what he's done there. Second thing is you can do a Hive and plus a UDF, so still you have a SQL query, but you need to add additional code in Python or Java or something like that. It's still hard to write, and it's almost impossible to read just by taking a look at it. It's very difficult to understand, and it's not as performant. Those two things will be generating MapReduce code, so they will be able to run, but still very hard to achieve. The third one is Spark. You can write Spark code if you know how. That would work. I mean, maybe not for terabytes, but for 500 gigabytes that should be able to achieve the job. But do you know how to write Spark code? That's a question. How many people do you know that can do it? With Talend, you can still achieve the same result, but it will be just like using Talend data integration, almost. So we're going to look at that. I'm not going to talk about the differences between Spark and MapReduce and the advantages of Spark and the limitations of Spark, so that you will have to see another video for that, but we're going to move on to see the input and output now. So this is how the input file looks like. Actually, there is more data to it, but I just wanted to explain it. You have a user ID, which basically is a username, could be a cookie hash or something like that, and then you have the visit start date, whenever the current action of the user started for that time. As you see here, you have user 1 has 3 times that he's been on the site, 448, 457, and 657. User 2 has only 1 record. The expected output should be 2 records for user 1 because 457 was within 30 minutes of 448. So we aggregated 448 to have 1 record. The session ID is a concatenation of user 1 and the first time, and then he has the first time he entered the site and the last time he ended that action. So this is going to be aggregation of these two rows. Now user 1 at 6:57, that's a whole new session because it's more than 30 minutes. User 2 of course has his own session ID. It's just been on the website once. Talend Studio, and this studio already has a license of a big data batch, at least, and this what you would need in order to create a Spark job. This is a job I've already made, and I assume you already know a little bit of how to build a Talend DI job. Just a couple of steps I've already done. First thing, I've created a schema for my input. As you can see here, it has a user ID, visit start date, and visit end date. Second part is we are creating a new job. When we're doing a Spark batch job, so in order to generate a Spark code, we need to create a big data batch job. And when we're doing that, we can select MapReduce code or Spark. In this case, I've created a Spark job. Let's take a look at the job. So the first job is kind of a naive version. I built this job exactly the same way I would do this job if it was just DI without working with Spark. So as you can see, I'm reading it from a file. It's going to be my local machine. It could have just as well been my HDFS or a Hadoop cluster or anything. I'm reading the file. First step, I'm going to sort the file by user ID first and visit start date. And that's because we want to achieve an aggregation based on those two things, and we have to have them sorted out first. Second part is a tJava row. Now this would go line by line as it would in DI, and will perform this code. As you can see, it's really short, it's not a lot of code. What we're doing is we're always keeping the context of three things: the current user, that was the user ID of the last row, the last user click, so the time of the last row, and the current session, which is a session ID we are going to create. This session ID is a concatenation of user ID and the visit start date. If you see the schema that goes out of it, it's the same schema, but we added a session ID, and we're going to later aggregate by this new session ID. So there are basically some if and else condition statements here. What basically we're doing is we're looking at the previous row we have kept in the context, and if it's the same user and it's been less than 30 minutes, then we are going to create the same session ID. If it's another user or it's more than 30 minutes, we're going to create a new session ID, which is the user ID and the new start date. After this aggregation, now we have a session ID, as I said, also added to the schema. So we are carrying for each record a session ID. And if those two records, or more than two records, have been within the same 30 minutes as the last entrance and were of the same user, we are going to aggregate them. We are using the t-aggregated row, aggregating by session ID, and just taking the other three fields: max user ID, that basically doesn't mean anything, min visit start date, so the very first time that this user have been in that session, and end date max. We're going to write it into a log. Just as well could have written it into a file or a file on HDFS, which is what we normally would do with a big data kind of job. So just before I show you the results, I want to show you that I'm running it on Spark, and in Talend you can run Spark in three ways. I'm not going to talk about that now, but we are using the local mode, which means this is generating Spark on my machine. I didn't install Spark or anything. I just have the Talend Studio, and it's going to run it with Spark using my machine and separating my machines by cores. So it's going to split the data just like it would on a cluster, only with the resources that I have on my machine. I already pre-ran this, and these are the results. Okay, so let's take a look at the results. If you look carefully, we see here that there's something wrong in the results of the first job that we built. Why is that? You can see that user 1 has 457, a session ID, even though user 1 had a session ID in 448. There's only 9 minutes difference between the two, so it should have been aggregated together. Why they did not create the right result? The reason for that is that we ran this job assuming that all the data is aggregated in one place, like it would be in a normal Java job. However, we are using Spark. Spark distributes the data, and we cannot make sure that all of user 1 records are on the same executor, and Spark will aggregate them together. So in this case, we see that one of the records reached probably a different executor, and so the data was not aggregated. We need to make sure that Spark knows to put users on the same executor. So all of the data of user 1 should be on one executor and not distributed between two executors. In order to solve this problem, I created another job, but this time I've added another component, which is a specific component for Spark. The tPartition is using the Spark transformation of partitioning, and I put it here between the part that I sort the data and to the part that I look at the data row by row according to the right order. I want to make sure that each executor will have all of the user ID that he needs to aggregate, so we cannot have the same user distributed between two executors. The way to do it is use this transformation. We put this in the middle, and we say that we want to partition this data by user ID. Now we are making sure that the partitioning is going to go the right way, and all of the same user will be on the same executor. The number of partitions mean basically usually it's good to use the number of cores that you are going to run. So if you have 100 cores or 1000 cores, you write here. Okay, so this would work. However, we still have one problem. Now we have added the tPartition. If you remember, before that we sorted the data according to user ID and visit start date. We need to make sure that the data remains sorted after we partition the data. However, when we look at Spark documentation, we see that shuffling the data in tPartition does not guarantee to keep the sort that happened beforehand. So basically there is a chance that although we sorted the data first, once we partition the data, we are not guaranteed to have the same sorting on the executors. And the other way around, if we reverse the two components, if we first partition the data and then we sort, we might lose the partitioning because sorting can do a reshuffle of the data. So neither of these two elements could go one before the other. They have to go at the same time, and that's a problem. In order to solve this issue, Spark has a transformation to do partitioning and sorting at the same time. And in Talend we can also use this. If you take a look at the components, there are two things that we can do. So initially what we did is we marked here the field that we want the partitioning to be done by, but we have here two more things. One is we can override the partitioning by using a custom class that we will write. The other one is we can override and insist on sorting while partitioning. So we do want to sort the data, that's for sure. And when I click this checkbox here, what I get is natural key order. That means that if I partition by this, I will also sort by the key, which is the user ID. That is not enough for our use case. The reason it's not enough for our use case is because we want to sort by both user ID and visit start date. In order to do that, we actually have to include both fields in the sorting. Now we still have one problem. So sorting is going to be fine because by default it's going to create a comparator and sort by user ID and visit start date, which are what we expect and what we want. But we are not partitioning in the right way. We wanted to partition only by user ID, and now we are partitioning also by the time, which does not make sense. There should not be more than one entry to the website within the same exact second by the same user. So we need to somehow override this partitioner. The way we do that is we click here, and here we will add some additional code. In this code, we have in the advanced settings, we have a custom partitioner that will override the partitioner. And in this partitioner, basically, we define the code to be, even though we are getting string and date, we want to only partition by the first incoming part, which is the user ID. So that will make sure that we are sorting by these two fields, but only partitioning by user ID. And now we have to add this part, the name of the class that we wrote, to here. And now the sort is no longer needed because basically it's done at the same time. So this would actually solve our problem and would work. So basically what we achieved here, what we made sure of, is that first the data will be partitioned by only user ID by overriding the partitioner, and also the data at the same time will be sorted by both fields, user ID and visit start date. So when the data of the user will get to an executor, we are guaranteed to have all of the data of the same user on one executor, and it will be sorted by the user ID and the visit start date. So the code will go row by row and will work in the right order. Now, when we run this job, as I did, you can see the results are correct this time. I hope this use case is useful for you and you can learn something about Spark and also how to work with Talend. I will add the partitioner code to the comments. Thank you for watching. Have a good day. Bye.